Hello students. In the previous video, we learnt about electromagnetic induction, that is EMI. Yes, we saw how can we induce or produce current in the coil with the help of magnetic field. What we did was we kept coil without any current in its stationary position. That is, electric field was kept constant and magnet was moved in and out of the coil. Yes, we changed magnetic field. So we could see that current starts flowing in the coil now. And this is why we call it as electromagnetic induction. As the name says, we induced the current with the help of changing magnetic field. We also asked you what will happen if magnet is kept stationary and the coil is moved near and away from the magnet. Well, let's answer this today in this video. And to do that, let us perform an activity. Let's keep a bar magnet stationary, say near a point Q, and move the coil towards and away from it. What do you observe? Yes, the needle deflects to one direction, say right. And when the coil is moved away from the magnet, the deflection of the needle is in the opposite direction, that is, say towards left. Thus, we can say that changing electric field and keeping the magnetic field constant will also induce electric current in the coil. Now students, in this activity, let us replace a magnet with current carrying coil with a greater number of turns. If you observe, both are coils with some number of turns, but one coil has larger turns than the other. Let us name both these current carrying coils. Let us say the coil with larger number of turns as a primary coil and the coil with lesser number of turns as secondary coil. Now connect both these coils as shown. Also connect a galvanometer to the secondary coil. Now when we switch on the current in the primary coil, we can observe that the galvanometer connected to secondary coil shows some deflection. This shows that a current is induced in secondary coil. So we say that a primary coil can induce electric current in the secondary coil. Can you figure out the reason behind this phenomena? Yes, it is easy students. Recall that a current carrying coil behaves as a magnet. So here, when current is allowed to pass through a primary coil, it behaves as a magnet, which when moved produces current in the secondary coil. Due to the effect we already studied called as electromagnetic induction. Do you know students, this principle of using two coils and producing electric current using electromagnetic induction is used in generators at power stations to produce electricity on a large scale. So students, let's quickly recall what we have learned. Thus, electromagnetic induction or induction is a process in which a conductor is kept stationary and magnetic field is varied, or magnet is kept stationary and electric field is varied. This produces a voltage or a potential difference across the electrical conductor and results in the production of electric current, that is electricity. Now students, can you know the direction of the induced current? Yes, we can know in which direction current is induced by using a simple rule called as Fleming's right-hand rule. According to this rule,
Stretch the thumb, forefinger and middle finger of the right hand so that they are perpendicular to each other, as you can see on your screen. Align your forefinger in such a way that it indicates the direction of magnetic field, and thumb in such a way that it indicates the direction of motion of conductor. Then the middle finger will show the direction of induced current. The simple rule is called Fleming's right hand rule or dynamo rule. So students, what we have learned is that when magnet is moved near a conductor, it induces electric current in the conductor. Or if magnet is kept stationary and coil is moved near the magnet, it also induces electric current. This phenomena of inducing current in a conductor by changing magnetic field or electric field is called electromagnetic induction or EMI, and the current so produced is called induced current. In our next video, we will learn about instruments that use this principle of electromagnetic induction to generate electricity. Can you guess such a device? Yes, you are right. They are generators. So students, in our next video, we will learn about generators.